All right, anybody on Zoom, can you hear us in the room?
Linda, I can hear you.
All right.
Can you hear me as well?
Yep.
Oh, yes,
Sounds
yes,
good,
we
Dan.
can hear you.
All right.
All right.
Oh, we can mute us while we
Yeah,
munch on some
fine.
chips. Right back here.
All right, good.
If you want to give maybe till, there's only a few people, or give it till like 10 after, just in case people are stuck in traffic.
Yeah.
I'm gonna go grab some chips.
They're good.
Thank you, everybody.
Oh, sorry.
But Gleason said there was a trauma if he wanted to take it.
Yeah.
Oh,
Easily.
oh, he's taking a shave.
Did you get some chips? Yeah, I'm listening to here. You get to motion.
I did see a Shake Shack, so. Oh, I shouldn't do this.
Well, now the weather. Yeah, I'm down to grab it.
You know when the workshop's open?
I'm gonna look for it.
That's why everybody sits in the background.
So this is by your date, like you share it, David?
Yeah.
Wow.
The last meeting was the first one we did.
I'm gonna look at the term unit.
I put home, just. Man, very good though.
Okay, true.
It's better than our normal, like on Google.
Mm-hmm.
It's not beta, but it's kind of like. You might eat it every day.
Sure, sure. He took us to ML Rose for lunch.
Oh, right down the street, that's good, yeah.
Yeah, I was like, this must be a lunch block. There's a ton of stuff.
Yeah, I'm that, and there's like, Canado Taco down the street, that's it. It's really good.
I haven't seen it.
He was like, if you want burgers, we're going here. But
What
not
was
tacos.
that?
Yep.
Dates.
I need to say that, like, I've got a couple of vendors, and we always get end up at Canado Taco, like, tacos, let's go have tacos.
And it's May 24th.
Yeah, so it's far away.
This day, yeah, I read TV. And still, it doesn't look too. I
I want to follow along. Do the feeling. Security.
And
In Jared, like, Jared's.
Kubernetes, having Kubernetes clusters.
Yes,
That might be good.
yep.
But really, like, Jeremy, education kind of keep our request from security in the loop, and then that's what I'm talking to the deck.
I'm not sure they really
All, you know, get their why. You know. Yeah, so, like.
I think it's a good initial tool.
We'll catch up.
All right. So, welcome, everybody. This is our second in-person OWASP meeting this year, so welcome to those of you that actually made it in person and hybrid, so we've got some online. Jeremy, unfortunately, looks like he dropped off, couldn't be here. He had a child engagement, so I don't have a whole lot of introduction, so
Sure.
I'm gonna let you take it away, Dan.
Sure. Yeah, thanks everyone for making it in this weather. Thanks everyone else for joining in online. I'm Dan Lorenc, the co-founder and CEO of a company called ChainGuard. But I've been working in open source security for a very long time. And so I'm going to talk a little bit about what is going on in open source and what we need to do together to secure it. So just a little bit of background on myself. I've been working on a bunch of open source projects. I helped co-found the SigStore project, which is trying to provide an authenticity layer to open source software supply chains. You can think of it like Let's Encrypt, except for code signing and open source. I helped start the OpenSSF, the open source software, the open source security foundation. And I've been doing open source myself for a very long time. I started the Minikube project for running Kubernetes clusters locally on your laptop. And I've done a bunch of other things in that space. It shouldn't be news to anyone, but software supply chain attacks are on the rise lately. We saw a huge high profile one a couple of weeks ago, or maybe a month or so ago now. It feels like years in software speak with the XZ utils backdoor, where an attacker spent years getting trust and getting maintainership in one of those widely used compression libraries in the world, XZ. And then they used that attack to pivot to another project, SSH, to insert a backdoor so they would get remote access to any system running SSH. That was caught at the last minute by somebody who just happened to notice that his CPU was spending a little bit more time in authentication than it should have been. And we all dodged a massive bullet that way. But this isn't new. These attacks have been happening both in closed source software inside of companies and in open source software on a rise for the last couple of decades. The big one that really put this on the map was the attack on SolarWinds back at the end of 2020, where an insider got access to their build system and used that to plant a backdoor. Instead of just attacking SolarWinds themselves, put a backdoor into the binaries built on that build system. And it was really clever and hid itself, and those binaries actually made their way all the way inside of the Department of Defense and other sensitive environments. This isn't a new threat. This has been known since the 1980s when computing was first getting started, and Ken Thompson was at Bell Labs. He played this awesome prank on his coworkers and then wrote a famous paper about it called Reflections on Trusting Trust. But he put a backdoor inside of a compiler that was self-propagating. So it put a backdoor into every program it compiled, and it even knew if it was building another compiler, and so it would insert the backdoor into the next compiler. To really hide his work, the backdoor knew if it was compiling a disassembler, and if it was compiling a disassembler, the disassembler would have a backdoor to hide the backdoor. So his amazingly smart coworkers saw the backdoor he put in, which was just a prank. When they tried to disassemble it to figure out where it was, the lines of code for that were completely gone. So he used this to build a self-propagating, completely transparent backdoor that was completely undetectable. He wrote a paper about that that basically proved unless you can trust and have reviewed every single line of code all the way back to the first one that was used to build the compiler that was used to build the next compiler, you can't build up any trust in modern computing. He won a whole bunch of prizes. That was one of his acceptance papers that he wrote. And it was so scary that everyone basically just blocked it out of their memory for the next 40 years or so and just pretended the problem didn't exist until attackers started noticing that the problem was still sitting around and started using it. We're seeing similar attacks in AI training pipelines as people insert malicious data into models that get hidden. Anything dealing with computer data can really easily hide itself inside of those pipelines. We as an industry spend tons of time on perimeter defenses and running our operations, running our systems securely. But what this is showing is that the supply chain itself and the entire software development lifecycle is a threat vector. And we as an industry, as we get good at securing one aspect of security, attackers just pivot to the next one. So this is like those old movies when somebody wants to break into jail, instead of jumping in over the electric fence, they just hide in the food cart that gets brought in a truck. And it's a whole new threat model that we really have to face as an industry together. Open source poses a bunch of unique benefits, but also a bunch of unique challenges to this. Open source is amazing. There's Linus Torvalds' law, which is that many eyes make every bug shallow. Open source is transparent. Anyone can contribute fixes. Anyone can patch vulnerabilities. But the terrible part is anybody that spent more than a couple of minutes reading YouTube comments quickly realizes that most people on the internet, or sorry, many people on the internet are not nice people. And so you're dealing with a threat model of basically attackers having full access to your source code, being able to hide things. The many eyes rule is good and it does help. But there's also this competition run every year called the International Obfuscated C competition, where attackers try to write very vanilla, or not attackers, contestants try to write very vanilla, plain looking C code that does incredibly confusing things when it's compiled. And it basically proves that even manual review is not good enough to catch a lot of these. You really have to trust the people behind all of the source code, which is really hard. The problem here, though, in open source isn't really specific to open source, right? As we saw with Log4Shell and as we saw with XZUtils, when a problem is found, you have an army of the best, smartest, most talented people that can be spun up overnight in seconds or minutes, in some of these cases, to reverse engineer these things. XZUtils was an incredibly sophisticated attack in there that took the world's best reverse engineers days or weeks to fully uncover how it was designed and what it could do. The problem, though, is in enterprises, right? Log4Shell was one of the most widely deployed vulnerabilities in the world. It was a vulnerability in the Log4j library in Java. It's the most widely used library and the most widely used programming language in the world. Log4j was actually running on the Mars rover. So it was one of the first intergalactic vulnerabilities that we've had to deal with. The problem is the way enterprises manage open source. Open source is great because anybody can download it and run it inside their organizations. Lawyers understand the risks. You can run things with allowed licenses, but that means it's pervasive and it gets everywhere very quickly. People don't do a great job of keeping track of where it's running or where which version is running. Compare that to closed source or proprietary software where it takes months or years to file a procurement ticket and you have to closely track which licenses you've used and where all that software is running just to avoid a bill. Open source gets everywhere very quickly. We saw this in Log4j really quickly. Everyone patched it over that weekend. And then within the next 6 months or 12 months, 72% of organizations had redeployed it somewhere else because they forgot about it after that initial weekend. Everyone spent panicking around it. Open source is secure. It's more secure by every metric than proprietary or closed source software because of all of those benefits. But organizations really do have to think about and change the way they ingest it in order to deal with this new wave of attacks. We're never going to prevent them all, but understanding where all that software is and which versions you're running everywhere, the key to be able to recover from these things quickly and to prevent them from being reintroduced later on. This diagram really puts it into perspective. When you start writing code today and you write code in a modern programming language like Python, Rust, Go, or Node.js, you're building something standing on the shoulders of giants. If you write a hello world app in Node.js, you pull down thousands of dependencies from NPM. By lines of code, I've seen stats saying anywhere from 90 to 98% of the code running in your infrastructure today is open source. Your stuff is that thin layer on top. And most of the security industry, all of the tools, all the SaaS tools, all the DAS tools, all the infrastructure monitoring tools, you really focus on securing that 2% at the top that you write and feel responsible for. But it's leaving that massive mountain of open source code underneath that's holding all of that up unsecured. The communities might be out there securing these things and patching things quickly, but if you don't even know what that is, if you don't have visibility into what's floating below the surface here on that iceberg, you're never going to be able to keep yourselves up to date and secure. This graph here, open source is everywhere, and the adoption rate is only growing. This shows 500 million up to like 4.5 trillion downloads. This is across Python, JavaScript, Java, maybe one or two other ecosystems. It's going up and to the right quickly. So this isn't really a new problem, but the rate at which open source is growing and being adopted is accelerating dramatically inside of enterprises. Unfortunately, though, the only thing growing even faster than this is attacks and malicious packages being uploaded to all of these registries. There's been a huge shift over the last couple of decades in the way that these registries worked. In the early days of open source, the only real way to download these things was from Linux distros or Linux distributions, where a small team of maintainers curated all of that open source for you. They picked stable versions, they backported patches to them, they dealt with the updates and maintenance of those. And if you ran apt-get update or yum install or something like that, you know you're getting things from a trusted vendor or a trusted community that you're working with. Debian's been around for 30 plus years and they do an amazing job securing their packages. But the shift that's happened is these language level package managers, where a lot of these packages are hosted, don't have that central curation model. So the command line syntax looks pretty similar between apt-get install or npm install or pip install, but there's a hugely different trust compromise that you're making there. When you run apt-get install, you're getting things from a small team that does a very good job and cares about security a lot. when you run pip install, you're getting things from PyPI where anyone can register an anonymous account and upload whatever they want to that. Typo squatting attacks happen there, account takeover attacks happen there. There have been a couple scary ones lately with domain takeovers. People register these accounts with email addresses that are then made public so you can see whose packages you're getting. And then people just forget to renew the domain names behind those email addresses. Every 6 months or so, someone remembers this, scans those package repositories just to find out which domain names have expired, spend a couple $100 re-registering those domain names and then doing a password reset on those email addresses. And now they can upload into those package sets that many enterprises might already be using because those packages have been sitting there forever. It's basically remote code execution into your environment through the development pipeline. And this happens all the time. There's not really anything in place to stop that. On the flip side, inside of enterprises, the most commonly complained about thing in dealing with open source is patching and updates. Open source moves quickly. You can adopt open source for free. Open source is free to use. You hear the sayings free as in beer. There's going to be some beer later across the street, I think. Free as in speech, free as in beer, but I think open source is free as in puppy. When you adopt one of these things, you're stuck dealing with it. You're hopping on a treadmill of updates and security patches and breaking changes that happen at the maintainer's discretion and might not happen at the same time as your enterprise release cycles. And so there is a large tax being faced internally by a lot of teams trying to deal with that rising adoption of open source. That's just one of the issues. The other huge problem here is CVEs. These are the way vulnerabilities get filed and disclosed. CVEs are going up and to the right, but inside most organizations, resources to deal with them are not. It's not that there are more vulnerabilities in the software. It's just that we're getting better at transparently knowing about them.
What is the CVE?
A common vulnerability, I never remember what it's
Enumeration.
Enumeration, thank you. Common vulnerability enumeration. The National Vulnerability Database is run by the US government. And it's a world writable database, and pretty much anyone can file a vulnerability against any piece of software. And there's very little quality control that actually happens and goes into that. They've been scaling that system to support more automation around the way vulnerabilities are reported and disclosed in there. And anybody inside of an AppSec team is stuck dealing with reports from all of their scanners that try to match those CVEs, those vulnerabilities up to the software that they're actually running. So it's this kind of transparency paradox where things look like they're getting much worse, but really we're just getting better about knowing about all of the unknown vulnerabilities that people are stuck dealing with on a day-to-day basis. Containers kind of make this problem much worse, and not because they're containers, but because they stand on top of every one of those other package managers. A container, something like a Docker file or something that's running inside of Kubernetes, isn't really a package manager in and of itself, but it stands on top of the language level package managers, which then stand on top of the distribution package managers. Developers curl pipe to bash inside of all of these things. And because they're so easy to use for developers, they put all of that control in the hands of developers. Developers can pick up a Docker file, write a Docker image, and install anything they want. Or 10 years ago, if you wanted a new system dependency installed across all of your servers, you probably had to file a ticket for your ops team. They'd review it, they'd make sure it was available from a trusted place, and they'd get back to you in a couple of weeks, and then it would be rolled out globally, and they had good patching and inventory management on that. Containers got rid of that whole ticketing system, basically. They let developers do whatever they want, and developers love to be able to do whatever they want. So as soon as the first wave of containers started rolling out, security kind of spiraled out of control because every one of these images has full access to all of those package managers standing on top of each other, inheriting all of those problems at every single one of those layers. And then there's no continuity across an organization. Every development team can pick a different base image, can pick a different set of package managers. They get different versions and SKUs that are upgraded on all of their own cadence. So combinatorically, the problem has completely exploded. To make this much worse, I mentioned CVEs are going up and to the right. It turns out that actually stopped sometime in February. The National Vulnerability Database, which is run by NIST inside of the US government, ran into some budget crunches due to all the continuing resolutions and budgetary issues in Congress right now. And they actually turned off processing CVEs sometime right around Valentine's Day. Yeah, it's somewhat terrifying, to be honest. CVEs are getting in, but they're not getting scored or annotated. Some weeks they don't even get added at all. You'll go weeks with nothing and then a dump of thousands all of a sudden. There are bills being passed to try to fix this situation, but as a global source of truth for all of the vulnerability information for all software, that falling over also has a huge impact on the entire industry. At a high level, this is somewhat depressing, but when you stack all of this up, most businesses building on top of open source are building on top of a house of cards. This is not a stable foundation by any means. It all works, but barely. And as soon as one of these things falls apart, like an attack on a very common package, the database running out of funding, anything like that, that house of cards can quickly come falling down. I just like this one. All of the security layers and all of these systems are basically best effort. The XZ attack happened because a common practice in open source code is to develop it inside of a Git repository and then to have a maintainer just export all of that Git metadata into a folder and just upload that folder somewhere on the internet. And everyone just trusts that it was actually from the real Git repository. You're throwing away all that nice SHA verification and all that metadata you use to actually check these things. The package repositories are mostly protected just by basic usernames and passwords. They've started rolling out MFA. I don't think any enterprise here would allow you to log into a system without multi-factor authentication today, but you can still upload a package to PyPI that's used by 90% of the Fortune 500 without it. It's a Cheeto inside of a door lock in most of these cases. It's security, but not really anything that would stand up to any level of scrutiny. What we have to do as an industry is basically just fix this. We have to start at the bottom and fix this from the ground up. All of these links in the supply chain are attack vectors, and attackers are very patient and will keep finding them. What the SolarWinds attack really taught us was that you don't have to be in the attack sites of a nation state threat actor. You have to be someone that sells software to someone that sells software to someone that sells software that is in the attack sites of one of those attackers. And if everyone else is doing their jobs, they're just going to find you and attack you first. Source code management systems, developer laptops, developer passwords, uploading to these package repositories, build systems themselves. They're all links to that supply chain. And the only way we're really going to address this is by improving security across the bar at every stage in that life cycle. This is a quote that I love here. It really points out the paradox that we all have to grapple with. You may be deceived if you trust too much, but you will live in torment if you don't trust enough. The choice you have to make is really don't trust any of the software in the world because you have no real reason to, or just don't write software and find a cave somewhere and live inside of it without power or electricity or running water. There's no real way to live in today's society without depending on open source software, but to do that relies on trusting thousands of strangers on the internet that you've never met and have no reason to trust, and probably wouldn't even shake their hand if you met them in public. So that was a quick overview, hopefully not too horrifying, but a glance into all the problems that we're currently facing in open source security. Any questions?
So with NIST not updating CVEs, is there any,
Comment on that one, yeah.
yeah, is there any talk, I think I had heard that, I just didn't realize it had been since February.
Yeah.
So is there anything, being done to catch up or get that to continue or?
So we started like this open letter to try to attract attention to the issue. It did get a little bit of attention and then the XZ thing happened and everyone forgot about this one. But no, there are some groups working on it. There's a bill that's supposed to, I've seen the draft of it. There's a bill that's supposed to hit the floor soon for markup to get some funding. This is a global utility used by pretty much everyone and they need $7 million a year in funding and they can't seem to find that anywhere inside of the US government. It's sort of crazy. I've heard there's like a slim chance it's going to get passed this year, but nothing terribly exciting. There are a bunch of other organizations standing up similar vulnerability databases and other things you can use in lieu of the NVD. But the flip side of that is that many of the government regulations say you must use the NVD and you're not allowed to use any of those other data sources. So if you just care about security, there's other stuff like GitHub has a vulnerability database. A lot of scanner vendors have their own and those can help in that, but they don't help if you're maintaining or selling software to the US government. So it's a problem that they both created and are forcing people to stay inside of and deal with.
Right, like most of those other tools like GitHub or anything relates it back to a CVE
Yes.
anyway, so
Yeah.
it's kind of like you need that
Yeah.
centralized place.
Yeah, GitHub is really good at the open source stuff. They have more metadata around open source vulnerabilities. They have fine grained, because if it's open source, you know exactly which commit something was introduced in, when it was fixed in. And the NVD doesn't have that level of detail because it has to do with all software generically. So the GitHub one is way better if you're only dealing with open source, but if you have, say, some VPN bug in an appliance that's sitting out front, GitHub, that's not in scope for GitHub. So there's really no other solution right now. Europe passed their own Cyber Resiliency Act a couple months ago, which kind of directed them to stand up their own database. Maybe that'd be good right now, but in the long run, that just means there's going to be two and you're going to have to patch all the vulnerabilities, even the ones that aren't in the other one.
Well, I guess, yeah, because then you got, one scanner calling it something, another scanner calling it something else, and then you never
Yeah,
know if you actually resolve that
Yes.
digital.
Yeah, sorry, I don't have better news. We're trying. I was supposed to talk to the Senate Committee on Commerce yesterday about this, but they canceled. They had about more important things to do, I guess, but.
I don't know much about AI training attacks. Is there anything you can kind of give an example what sort of malicious behavior that could entail?
Yeah, I've seen a bunch of scary papers about this, and I'm not an AI expert by any means, but if you think about model training in general, you're taking a whole bunch of untrusted data from all across the internet, passing it through this complicated process and getting this giant blob that you can't really reverse engineer on the outside. So it sort of looks like taking a whole bunch of source code, running it through a compiler and getting some kind of executable at a high level. But there have been a bunch of attacks that show if you can control, like, say, a single-digit percentage of the data going inside of a model and you roughly understand the training process, that you can inject malicious behavior into that model. And that's like a similar problem where you have to be able to trust the source code going into your executables, but there's way more data coming from way more people. And yeah, it's kind of scary.
So the people using it need to review it just like it came out of human being.
Yeah, but these are just random Wikipedia pages, that kind of thing, getting fed into training these models.
On your iceberg picture where before we had, I think it was like, what, like 98% of
Yeah.
applications are open source. Does that take into account how much of the application is like functions that are actually being used? Because I think there's some
Yeah.
other stat that,
Yeah,
yeah, like even though you're using a package, you're using like 1% of what's in any given package.
yeah, there's a bunch of research around that. Depending on the programming language, it's really hard to ever prove, like in some of the dynamic ones like Python or JavaScript, like you can't actually prove if a function is going to be called or not because they're so dynamic and they can change behavior at runtime and everything like that. Compilers for static languages are pretty good about like dead code removal and tree shaking and everything that way. If you have really good knowledge of your first party source code, then there's some tools that'll help you filter out just noisy vulnerabilities. There's also a bunch like that only apply on Windows. And if you know you're not running on Windows, then you know you're fine. And you can kind of trim some of the vulnerability noise down that way.
Yeah, we just get a lot of the, oh, well, we're not really using that vulnerable function, so, you know, it's not exploitable, and I'm like, can you prove it? And then can you prove you're never gonna use that function? And so,
Exactly. Yeah, with manual review, maybe you can get there, but yeah, I'm always kind of skeptical on the automated tools just because you can always run eval and then throw some string inside and make the code do whatever it wants later.
That's an interesting thing because like for like one for Jay, it's like, oh, we removed this Java, Shredder class, whatever. And because the vulnerability is gonna show, just look at metadata, your version and what's in it, it'll sit there and pop. And so you have to go to your vendor and look for like, oh, did you do this? They have to change the proof of concept or like proof of like, we have actually done this.
right,
It gets on and on and on and on.
well, you got that, but then, they turn around and like, it changed, and then all of a sudden you're
Yeah.
like, oh, we just missed this, and now they're using it.
Yeah, it is whack-a-mole.
SBOMs, I didn't talk about SBOMs at all, software bill of materials, but that's also gonna make the transparency a lot better, which will make the noise problem a lot worse until we get better at filtering that type of thing out. Software bill of materials is an idea that whenever you buy software, the vendor will give you a list of all of the open source components and third-party components and everything inside of it for you to do something with, I guess, most likely query a vulnerability database. And they're really just lists of components. They don't contain any of that, enough of that fine-grained metadata for you to really be able to do any intelligent filtering on your own. So it just gives you more queries to run and more noise to deal with.
Right, which just gives, like, a lot of the SCA vendors are trying to figure out how to do reachability analysis, which I'm like, yeah, that's fine to have you prioritize, but you still have to fix it all.
Yes.
You never know what you're gonna use.
Yeah, another fun one, the Linux kernel team, so they maintain the Linux kernel. For decades, they've resisted actually publishing CVEs for vulnerabilities in the Linux kernel because it was too hard to really judge whether something was exploitable in a system that's so low level. They changed their stance about 6 months ago and they became what's called a CNA, so they can report their own vulnerabilities, and they went the complete opposite direction. So anything that could ever have a chance of being exploited, they publish vulnerabilities for now. They have some rules around it and they only publish them when the vulnerability's actually been fixed and there's fixes available and everything like that. So the action in every one of these cases is just update to the latest kernel. But people on older kernels now have thousands and thousands and thousands of vulnerabilities flying at them because they're publishing all of this information. All right, thanks everyone for coming.
All right, thank you.